Okay guys, 9.1 consolidated activity. So you definitely want to make sure that you tune into this video as well because you have a set of questions down here at the bottom that are going to be very helpful for your first question on homework. All right, so we are dealing with this Uncle Eddie and McKenna and Laura situation. So Uncle Eddie asked McKenna and Laura to order 54 new wheels. So 54 new wheels for the 21 skateboards and bicycles in his repair shop. How many bicycles and how many skateboards are in Uncle Eddie's shop? Okay, so we're gonna go through, we're gonna define the variables. So the variables are going to represent whatever you're looking for. So if we look at this question, it says how many bicycles and how many skateboards are in Uncle Eddie's shop. So we are looking for the number of bicycles, and you can do anything you want. You can do X and Y. I'm gonna do B for the number of bicycles. And I'm gonna do S for the number of skateboards, just because it makes sense in the context of the problem. Okay, so what do we know? There is one condition in the problem related to the total number of bicycles and skateboards. Okay, so what do we know about the total number of bicycles and skateboards? It's highlighted. So the total is 21. So if we think about the number of bicycles, which we said was going to be B, and we add the number of skateboards, which we said was going to be S, that total has to be 21 vehicles based on the problem. Okay. Letter C says there's another condition in the problem related to the number of wheels. Express that condition as equation using the variables you defined in part A. Well, what we know is that the total is 54 wheels. But there's information that's not in this problem that we, number one, know, and number two, we need it in order to write this equation. So we need to take into account the number of wheels there are on a bicycle and the number of wheels there are on a skateboard. So bikes, we know, have 2 wheels. And skateboards have 4 wheels. And if you didn't know that, don't worry, now you do. So each bike has 2 wheels. So I'm going to take 2 times the number of bikes, and that will give me the total number of wheels. So if I have 3 bikes, 2 times 3 gives me 6 wheels. And then I'm going to add 4 wheels times the number of skateboards, and that total has to be 54 wheels. Okay, so now we're going to use our work from parts B and C to write a system of equations that represent both conditions. So you already have the 2 equations. To write it in a system, all you need to do is put the equations in this one-sided curly bracket. So again, we are not Pablo Picasso. This is not art class. Do the best you can with the curly bracket here. So I'm just going to write my first equation, which is B plus S equals 21. And my second equation, 2B plus 4S equals 54. Okay, so that's my system. And you can see too, if I draw a little squiggly line, you can see from here down to question number 2, like that's how we write a system of equations, the curly bracket, and then the 2 equations within the curly bracket. All right. Letter E, in the opener, you showed that 15 bikes. Well, we didn't do an opener because we're not in class. So we are just going to be checking our solution in the system. You have a lot of homework questions that just involve checking the solution within the system. So we are looking at 15 bikes and 6 skateboards. So I'm going to highlight that. So we want to show that 15 bikes and 6 skateboards is a solution to the system that we wrote from part D. Okay, so equation number 1, B plus S equals 21. So number of bikes plus number of skateboards equals 21. So we are told that there are 15 bikes and 6 skateboards. When I add those together, I get 21. And that's what I wanted. 21 is equal to 21. So we're good. The first equation works. We still need to check the second one. My second equation is 2b plus 4s equals 54. So for bikes, again, I'm substituting in 15. And for skateboards, I'm substituting in 6. And our goal is to show or check to see if that gives us 54. So 2 times 15 is 30. 4 times 6 is 24. And 30 plus 24 is 54. And that satisfies our equation. Okay, so this 15, 6 is a solution because it satisfies both equations. Okay. All right. Number 2, suppose each system of equations below represents a bike and skateboard scenario similar to the one above. For each system, describe a problem situation that could be represented by the system. Okay. Then determine the combination of 9 and 8 bikes as a solution. So we are, number 1, going to describe the problem that's represented by the equation. And then we're checking to see if 9, 8 is a solution. All right, so first column right here, what problem situation is represented. So I'm looking at this system of equations and I'm comparing it to the one that we wrote above. So we said that B plus S had to equal 21. That was the total number of vehicles. So this is different because it's equal to 20. So we have 20 vehicles. And our second equation had to do with wheels. So up above, we had 2b plus 4s equals 54. Now we have it equal to 50. So we have 50 wheels. 20 vehicles, 50 wheels. My second system, 17 vehicles and 50 wheels. And my last one, 17 vehicles, 48 wheels. And again, I got all of these by just comparing the change from these systems from the first that we wrote up above in part D. All right, so remember, if we are checking 9 bikes and 8 skateboards as a solution, it has to work for both equations. So I'm gonna start with the first equation. So 9 plus 8 equals 20 by substituting the 9 in for the bikes and the 8 in for the skateboards. So when I add 9 and 8, I get 17. 17 does not equal 20. Okay, I can check the dollar amount. Oops. Get out of here. There we go. All right, I can check the dollar amounts by substituting 9 and 8 in. So 2 times 9 plus 4 times 8, and I'm checking to see if that equals 50. So that would give me 18 plus 32. Does that equal 50? And it does. Okay, but in order for something to be a solution, it has to satisfy both. So while this is true, the first equation is not. So this is not a solution because it didn't satisfy both. Let's check the second one. So 9 and 8, 9 bikes. 9 plus 8 equals 17. 17 equals 17. That's true. Let's check the dollar amount. So again, substituting 9 in for bikes and 8 in for skateboards. So that gives me 18 plus 32. 18 and 32 equal 50. So 50 equals 50 is true, sorry. Okay, so because both equations are satisfied, this one is a yes. Because both equations in the system are satisfied. Right, we're still going to check that last system. So 9 plus 8 equals 17. 17 equals 17. That is true. And now I'm going to check the dollar amount. So 2 times 9 plus 4 times 8. And this time the equation says it's equal to 48. Okay, so we know from above that this is 18 plus 32. And 18 plus 32 is 50, which is not equal to 48. So because it does not satisfy both equations, 9, 8 is not a solution to the third system. Okay, so I hope that example number 2 kind of sheds some light on the whole what is a solution question, because you can see in the first system and in the third system, one of the equations works, but the other one doesn't. So it does not matter. It has to work in both equations. The ordered pair, the solution, must work in both equations. Otherwise, it is not a valid solution. This problem that we did at the bottom here, I have given you a little starburst here. This is going to help you complete number 1 on your homework tonight.